Okay, question number 6. The diagram shows the displacement time graph for a particle executing a simple harmonic motion (SHM). So the question required to sketch the graph of velocity time, acceleration time, kinetic energy time, and potential energy time. So before we start to plot this graph, we have to identify first. The displacement time graph here is actually a sine graph. Okay, sine graph. So we have to write it down as a sine omega t. Now, don't worry about the parameters, so no need to input any parameters here. Okay, so just bear in mind this is a sine graph. Okay, so let's go to number 8. A is required to find the velocity. So we know that velocity is equal to dx over dt. Okay, so you differentiate the displacement, so I will get a omega cos omega t. So you know that now your graph is become a cos graph. So cos graph will be like this. Okay, where the maximum here is a omega and the minimum is negative a omega. Okay, done. Now B is required find the accelerations graph. Okay, so acceleration is a equal to dv over dt, is the rate of change of velocity. So I will get negative a omega square sine omega t. So if you differentiate the velocity, so what you get back is actually a negative sine graph. Okay, it's very beautiful, hopefully. And you know that the amplitude here will be a omega square and the minimum here will be negative a omega square. Okay, now part C. Part C is required to find the kinetic energy. Okay, kinetic energy of this system. Okay, okay, let me open another one, not here. Okay, so see, I want to find the kinetic energy. So again, what is the definition of the kinetic energy? It's actually half of mv squared. Now bring the m down just now, the v down, which is the a omega sine. Sorry, a omega. Sorry, it's not sine. Okay, okay, it's not sine. I deleted it. It's not sine. It's actually cos omega t. Okay, sorry, it's not sine. Bear in mind, it's not sine. So then I will have half of m a square omega square cos omega t. Okay, so how suppose the graph looks like? Okay, so the graph is supposed to be look like something like this. Okay, okay, so it's supposed to be look like this. Okay, now part D. To find the potential energy of this system. Okay, now see that I just now I draw a dotted line. Why? Because we know that in an oscillation the total energies will be equal to potential energy plus the kinetic energy. So my potential energy is actually total energies minus kinetic energy. So I have to minus away. Okay, so means that the maximum here will be the minimum here will be the maximum. Did you see that? Okay, so that's it.